Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fuad bin Anuar. I'm from BNMA. Okay, I want to Allah Subhanahu wa Taala because of I already complete this PSM. So I need to thank you to my supervisor, Mr. February Ibral, okay, for guiding me to complete this PSM. Okay. My project is design study on cutting tools, validation and collector for semi-autonomous movement. This is a time chart for PSM2, start from October until now on January. Okay. Why we need to develop this project? Okay. Because of robotic technology commonly used in most populous area in Malaysia, also common uses in our life in nowadays, such as washing machine, vacuum cleaner, and so on. So robotic technology is defined as a machine can be automatically controlled, reprogrammable, multi-purpose, manipulative, programmable in three or more axes. Okay, for that, by using the robotic technology, it can be used to achieve complete automation and production process. Okay, so for for our project, we need to build lawnmower that can in fully automatic. Okay. About the problem statement. Okay, there is many type of lawnmower in the market. So all these have a various type look design and also various type of cutting tools design. Okay, so most of the lawnmower in the market, okay, are using for areas such as school field, football field, golf field, and around their home area. So because of that, generals in the plantation area mostly prefer traditional method such as manual labor, grass cutting job by using sachet and also use paraquat poison in their orchard. And so because of that, we need to build up a lawn mowing that can be offered at various condition of area with the various type of grass. Okay. So for the objective for my project is first study of design mechanism for cutting tools, orientation and collector for semi-autonomous mower to analyze the design of cutting tools and orientation and collector for semi-autonomous mower. So to fabricate and analyze the design for cutting tools, orientation and collector for semi-autonomous mower. Okay, so my project scope is investigate overall about cutting tools has been used for mower machine, design the machine, the mechanism that's suitable for the semi-autonomous mower project. Okay, number three is analysis the design project by using the application system CATIA V5. And then comparing the design project with the current design that's available in market. And lastly, fabricate the cutting tools, orientation and collector for semi-autonomous mode. Okay. So for the next topic is literature review. What the literature review, this chapter will be focused on the information, the research and the result of the study about the design and analysis of cutting tools, orientation and collectors and autonomous mower. In terms of lawn mower types, material lawn mower, cutting tools, power source of lawn mower, cutting tools and technical movement and lawn mower cutting tools. So for the cutting blade, the performance of cutting blade is important to obtain desired cutting height of grass. Okay, most of mower use casting engine to transmit rotary power to the cutting blade from Calvada. This is because the mower got stuck by grass itself if the blade cut through the grass and collide with the underlying ground. Okay, so the research from the journal paper in is needed to get information about the cutting rate for this project. Next is about the lawnmower engine. Okay, by using the internal combustion engine, it can produce more output torque. Okay, because of the cutting rate can operate in various conditions of the string. Some work behind lawnmower use two-cylinder engine, four-cylinder engine, and typically more efficient and eco-friendly compared to the two-stroke cylinder engine. Okay, so most of the lawnmower in the market are using the internal combustion engine as a power transmit to cutting rate by the rotational machine. Okay, so this from Leach 2020, currently 99.8% of global transport is powered by internal combustion engine. Okay, and 95% of transport energy become from liquid fuel made from petroleum. So because of this, why the most of the lawnmower in the market are using the ICE engine, internal combustion engine. Okay, this is a methodology for my project. So now we phase 2, okay, prototype CAD development until the product benchmarking. Okay, for the this project, we use two types of product benchmarking. First, user experience study, UHC, and the second is we do a market survey. We call a product comparison. Okay. From the user experience study, we conduct two online interviews survey with some potential consumer that uses lawnmower from the aftermarket. Okay, then UQ result were analyzed and delivered in the graph form. Okay, and this is the sum of the result from if you question. Okay. First, what are the type of the problem? We ask the consumer what type of the problem. Okay, so 40%. Okay, 40% from our potential customer are from the palm oil plantation. So, and then the second is how do you rate the safety of the current method and your plantation area? Okay, 75% decide that the currently method is danger method. Next, product benchmarking, we use a market survey. Okay, from this survey, we collect the data from the various of lawnmower design and concept. Okay, then the lawnmower that was found come in many variants such as semi-autonomous and autonomous, and also in manual control. These are either made by innovation and fabricated or manufactured such as Bana, result of product comparison to break in form of pie chart. Okay, so this is a picture that the comparison type of lawnmower that in the market. Okay, so we come up with the result. Okay, so set the parameter, then from the parameter we got the result and the description. So the parameter, first parameter, we decide the power source from the lawnmower that in the market. Okay, so as we saw, the 75%, okay, 75% of the lawnmower in the market are using engine, internal combustion engine, and 25 are using battery or motor, uh, electric motor for their operation. Okay, and then the operation mode, okay, 37% using a manual, okay, a manual operation mode, and 38% is semi-autonomous mode. Okay, and then brake operation, brake for data for brake operation. Okay, 100%. Okay, that the lawnmower in the market are using rotary movement of the brake operation. Okay, and we also material housing, data for material housing, okay, and then 60% material for the lawnmower is using steel, and so on. We got the 10 parameters, okay, to get information about the lawnmower in the market. Okay, from the survey, so we come up with the morphological chart. Okay, from morphological chart, we sketching an idea. Okay. Six sub-function. Okay, the first sub-function is about the cutting tools. So from the cutting tools, we got 4 sketching. Okay, then the operation mode. Okay, sub-function for operation mode, we got 2 ideas. Okay, and then for sub-function for mounting, we got 3 ideas. And then for sub-function drive mechanism, we got 4 ideas. And the joint, we got 2 ideas. And power source, we got 2 ideas. Okay, the power source, 2 ideas is for engine and for electric motor. Okay, for the joint, idea first sketching is sliding. Okay, sliding method, and then the sketching for number 2 is use slot or lock. Okay, and then the sketching for drive mechanism. Okay, drive mechanism, that means how the cutting tools operation, okay, connected to the engine. Okay. Okay, so the first sketching is the cutting tools operate by using bell. Okay, and then the sketching number 2, the cutting tools operate direct to the rotational of the engine. Okay, and the idea for sketching number 3, that got 2 cutting tools. Okay, they're controlled by one engine. Okay, and then the sketching number 4 is the engine and the cutting tools. Okay, location is vertical, then got the bell, okay, to change the ratio of the rotation. Okay, so for the sketching sub-function mounting, okay, sketching one for the sub-function mounting is adjustable height. Okay. Okay, and then the sketching number 2 for mounting, there is a fixed mounting. Okay, and then the sketching number 3. Okay, for mounting, there is adjustable mounting. Okay, for the operation mode, sketching number one is rotational movement of cutting tools. Okay, and the sketching number two is vertical operation mode for the cutting tools. Okay, and then the sketching sub-function cutting tools. Okay, for sketching number one, okay, the cutting tools at the end of the shaft. Okay, and then got the two cutting tools blade. Okay. And then sketching number two got the four cutting tools blade. Okay, and sketching number three is all of the uh, shaft of the flank of the uh, cuttings because it's the to cut the grass. Okay, and then the sketching number four is three uh, so three surface for cutting tool or plate to cut the grass. Okay, next. Okay, so from the previous sketching, so we come up with the conceptual design. Okay, from the design number one, there is a combination from A1 plus B1 plus C3 plus D2 plus E1 and plus F1. Okay, that means the cutting tools selected is at the end of the flank. Okay, there is two cutting blades at the end of the flank. Okay, and then the mounting of the cutting tools. Okay, and adjust for the height. Okay, so it can going up and going down to cut the height of the grass. Okay, and then the design two is combination of A3, B1, C1, D2, E2, and F1. Okay, the cutting rate that they use is the straight of flank. Uh, that means the all of the length of the cutting tools it can cut the grass. Okay, and then the mounting of the cutting tools also can flexible. That means can move up and down for adjust the cutting height. Okay, but the mechanism of the movement of the cutting height use X bar. Okay, then got the motor for adjust the base plate of the cutting tools. Okay, and the design number three is combination of A1, B1, C2, D1, and F1. Okay, so this design is fixed uh, cutting height. Okay, that means the height of cutting tools cannot adjust. Okay, and then we use blade that got two cutting blade at the end of the flank. Okay, and then the operation is using engine. Okay, that transmit the rotational engine by using belt. Okay, the, the advantage of this type of operation mode is it can uh, change the ratio of the engine rotational and cutting speed, cutting tools, rotational. So from the tree design on the conceptual design, we need to select the best design that we so we use pulp method. Okay, we use pulp method with the 10 of engine characteristics. The first characteristic is cutting height. Number two, design cutting blade. Body structure strength, cutting speed, torque of all of the engine, safety, maintenance, dimension, power transmit, and number 10 is ability working in uneven space. Okay. So we put the weight for the engineering characteristic. Okay, and important is for this method, we set a datum. Okay, we set the datum by using the spider ILDO2 SD. Okay, and that show in the top of the left mission. Okay, picture. Okay, so from the part method, so we got the higher score of the part method is design number one. The second is design number two, and the lowest score is design number three. Okay, so we see the total. Okay, for design number one, we got the total plus is 12. Okay, and then total of negative is 2. Then the design number 2, total for plus symbol is 10. Okay, so the total of negative symbol is also is 2. Okay, but on the design number 3, total positive is 6. Total negative is 7. Okay, so when we calculate the overall score with the weight total and weight positive total and weight negative total, we got the weighted overall score. Okay, so 22 score for design number one. Okay, so why the design number one is got the higher score? Because what this specification in the spider ILDO2 SD have, so it also have at the design number one, so what we need for the our long haul machine. Okay, so for the primary result, we come up with a design selection. Okay, from the design selection, first we design back with the proper sketching. Then we put the dimension, okay, the dimension of our design before we design or we sketch on the CATIA V5. Okay, so prototype CAD model development, okay, using CATIA V5, come up with the design for the semi-autonomous motor cutting. So for the design, there is three main part. Okay, the first main part is the cutting tools. Okay, the second is the base plate for the engine mounted, and the third part is the um, frame. Okay, frame to make the this plate can move up and down to adjust the cutting height for the cutting tools. Okay, then from the design, okay, we come out the cutting blade analysis. Okay, for the cutting tools, we use three meter of steel. There is my steel, stainless steel, and titanium alloy. Okay, there is the translational result, and then there's the one misses result. Okay, there is the cutting blade frame analysis. Okay, three types of material that we compare. First, we use mild steel, okay, aluminum alloy, and then constructional steel. Okay, that's it. This is the result for bone misses. Okay, at the upper and the lower is result for translational. Okay, for the blade frame analysis. Okay, and the third analysis is base blade analysis. Okay, uh, the type material that we use is mild steel, aluminum alloy, and constructional steel. Okay, the upper analysis is one misses, and the lower analysis is translational. Okay, so the result, all the result of analysis is on this table analysis. Okay, for the cutting tools analysis, okay, we use three types of material: mild steel, stainless steel, and titanium alloy. Okay, and we got the bone misses 3 to 2.457 for mild steel, 6 to 38.48 for stainless steel, and 1001.3 for titanium alloy. From the all data that we got from the analysis, we come up with the factor of safety. Okay, so factor of safety for cutting tools that using my steel material is 1.15. Okay, safety factor for stainless steel for cutting tools is 30.42, and then the safety factor for cutting tool that using titanium alloy is 12.05. Okay, and then for the cutting blade frame analysis, that we use three type of material, that is my steel, aluminum alloy, and constructional steel. Okay, the safety factor for my steel, we got 0.26. Okay, and then for the aluminum alloy, we got 0.18, and then the safety factor for constructional steel for cutting blade frame analysis, we got 0.12. Okay, so and the last for the base blade analysis that mount the engine, we also use three type of material. There is my steel, aluminum alloy, and constructional steel. Okay, safety factor for my steel, we got 2.24. Aluminum alloy, we got 1.43, and constructional steel, we got 1.06. Okay, so from the table analysis, okay, we decide to for the cutting tools. Okay, we decide to use the stainless steel as a material, okay, to use for our design. And then for the cutting blade and the base blade, okay, uh, so we decide to use the constructional steel as a material that we use uh, to build our lawnmower machine. Okay, so this is a final design, okay, for the lawnmower. Okay, in that we call a rocker boogie mower. Okay, so the conclusion from this project, the design and development process of prototype in this study produced with the high value of quality as validated by UEQ data analysis through market survey, and the concept of cutting blade has been generated accordingly to various part selection and rating method by using CATIA V5 software and 3D prototype design of adjustable cutting blade for semi-autonomous mower using rocker-boogie mechanism was produced. Pattern was tested to finite element analysis or FEA, such analysis to test and verify the strength of new design according to different type of material. To outcome of this project, the outcome of this project has success the producing a prototype design that solve the problem state in problem statement section, which is to design mechanism for cutting tool, orientation, and connector for semi-autonomous. That's all. Thank you.